On March 21, 2026, Elon Musk stood in a decommissioned power plant in Austin, Texas, and said something that sounds insane. He said all the chip factories on Earth, every fab, every clean room, every TSMC and Samsung facility combined, produce only 2% of what Tesla and SpaceX will need. So he's building the other 98%. It's called Terafab, and if it works, it will be the largest semiconductor facility in the history of civilization. This is AI Wire Daily. Here's what Musk is actually building. Terafab is a semiconductor fabrication plant, a chip factory jointly owned by Tesla, SpaceX, and xAI. The prototype is going up right now at the Giga Texas site in Austin. Two massive buildings on the North Campus. One makes chips for cars and humanoid robots. The other makes chips for data centers and AI. The goal? Produce 1 terawatt of compute per year. 1 terawatt. 1 trillion watts of computing power per year. To put that in perspective, that is 50 times the current total global output of AI chips. Everything Nvidia ships. Everything TSMC makes. Every GPU in every data center on Earth. Add it all up, multiply by 50. That's what Terafab is designed to produce. Musk didn't describe it as a business, he described it as a prerequisite. His words, "We either build the Terafab or we don't have the chips, and we need the chips, so we build the Terafab." He's not doing it because it makes financial sense. He's doing it because without it, his other plans, millions of autonomous Teslas, an army of Optimus humanoid robots, AI orbital infrastructure, simply cannot happen. The chips don't exist. The fabs don't exist. So he's going to build them. On April 7, 2026, Intel announced it was joining Terafab. Intel stock surged 11% in a single day. This matters more than it might seem. Intel has spent the last 3 years getting beaten up. Nvidia took the AI chip crown. TSMC took the advanced manufacturing crown. Intel looked like a company that had missed the most important technological shift in a generation. Then, Terafab called. Here's why Intel's involvement is significant. There are only 3 companies on Earth currently producing sub-5 nanometer chips at scale: TSMC, Samsung, and Intel. The chips that power frontier AI require this level of precision. You can't just build a factory. You need one of 3 companies on the planet to work with you. Musk chose Intel. Intel's statement was simple. Intel is proud to join the Terafab project with SpaceX, xAI, and Tesla to help refactor silicon fab technology. Refactor. That word is deliberate. They're not just building a factory, they're redesigning how chip factories work, putting design, fabrication, packaging, memory, and testing all under one roof. Today, making a chip requires shipping wafers between multiple facilities across multiple countries. Terafab wants to do all of it in one place, in Texas, in America. That's a geopolitical statement as much as a technical one. The chip shortage of 2020 to 2023 broke supply chains and cost the global economy hundreds of billions of dollars. Cars sat unfinished on lots, waiting for $5 chips. Hospitals couldn't get medical equipment. Factories shut down. The cause was simple. The entire world had outsourced its most critical technology to a handful of facilities in Taiwan and South Korea. Taiwan sits 100 miles from China. If that situation becomes unstable, global chip production collapses. The US government has been spending hundreds of billions through the CHIPS Act, trying to build domestic alternatives, but progress has been slow. Terafab is Musk's answer to that problem. Not a government program, but a private industrial project built with private capital, moving at private company speed. The prototype fab starts small batch production of Tesla's AI-5 chip in 2026, volume production in 2027. The long-term goal, 1 million wafer starts per month. That's not a semiconductor plant, that's a semiconductor empire. The full-scale Terafab, location still undecided, is estimated to cost $5 trillion, more than the GDP of Japan, for a chip factory. None of this is guaranteed to work. Building a semiconductor fab is one of the hardest engineering challenges in human history. TSMC took decades and hundreds of billions of dollars to get where it is. Intel, despite being one of the best in the world, has struggled to compete at the cutting edge. Yield rates, contamination, lithography precision, every step is harder than the last. Musk has a track record of hitting ambitious targets slower than promised. SpaceX has also repeatedly shown he can eventually get there, but eventually is doing a lot of work in that sentence. And there's a market question. If Terafab produces 50 times current global AI compute output, who buys it all? The entire premise assumes AI demand will grow exponentially, that humanoid robots will need billions of chips, that orbital AI infrastructure is coming. Those are enormous bets. But then again, someone said the same thing about rockets. 2 weeks ago, we covered BitNet, Microsoft's AI model that runs on your laptop CPU with no GPU at all. Today, we're covering Terafab, Elon Musk's plan to build enough chips to power 50 worlds. These two stories seem like opposites. One says AI needs less hardware. One says AI needs infinitely more. They're actually both true simultaneously. The edge inference market, everyday AI on your device, is moving towards smaller, cheaper, more efficient models. The frontier training market, the AI that builds the next generation of AI, is growing at a rate that makes even $7 trillion look like a down payment. What Terafab tells you is that Elon Musk doesn't think we're close to the limit. He thinks we haven't even started. The question is whether he's right, or whether he's building the most expensive monument to optimism in human history. Either way, it's going to be interesting to watch. This is AI Wire Daily,